We're going to explore a demonstration which organic chemists, especially students in the second semester, will find both useful and will encounter in the laboratory when they do a qualitative analysis experiment with alcohols. The three alcohols that I'm going to test are primary alcohol, 1-hexanol, a secondary alcohol, 4-methyl-2-pentanol, and a tertiary alcohol, 2-methyl-2-butanol. Okay. These are all conveniently liquids, but I presume this could be done with solid alcohols, although that's for another day. We're going to use for our test chromium trioxide, water, and sulfuric acid. Now this is chromic acid solution, and chromic acid solution, because it has a +6 oxidation state for the chromium, is considered carcinogenic. So what you have to do when you run this test is to put on your safety gloves and safety glasses. And it's also probably pretty good, because there's sulfuric acid in there, to wear some kind of covering for your clothes. This stuff is very unforgiving. It gets on your clothes. You'll soon find, after a short while, some holes in it, and you can talk to my wife about this. She is very familiar with the holes that I've put in my clothes. So what we're going to do then is to do this test, and this test is designed to distinguish between primary and secondary alcohols, 1-hexanol and 4-methyl-2-pentanol, and the other type, 2-methyl-2-butanol. All right, so let's start out. Let's take some 1-hexanol. Just need a couple of drops of the material. Just put it in there, a few drops. Okay. And the solvent that we're going to use is acetone. Okay, so let's put some acetone in there. Don't need too much. All right, and we're going to then take the chromium trioxide and sulfuric acid. And you'll see this is a very dark orange-brown reagent. You can see that in the dropper, an orange-brown reagent. Okay, let's take our solution. Now this is 1-hexanol, and let's add the reagent. You can see there's an immediate color change. We went from the dark orange-brown, which is evidence for the chromium +6 oxidation state, to the green color, which is indicative of the Cr+3 ion. And so we have a reduction on the chromium in the chromic acid, and we have an oxidation of the alcohol. Now in this case, because there's some water in it, the primary alcohol gets oxidized up first to the aldehyde, and then with the water present will become oxidized up to the carboxylic acid. So right now we've got hexanoic acid in this test tube. But very clearly the primary alcohol reacted very swiftly to give us the oxidation product and reduction indicated by the +3 oxidation state of chromium. Okay, so that's the first one. Let's look at the second one. Now we've got 4-methyl-2-pentanol, our secondary alcohol. Let's take a little bit of that. All we need is a couple drops of that. Put that in our test tube. A few drops of that. There we go. Put that up. Now let's take some more of our oxidizing agent. Oh, got to put the acetone in there. When the acetone is used as a solvent, by the way, this reaction is called the Jones reaction. And so let's take our chromic acid once again and see what happens when we drop a little bit in there. You can see that almost immediately we get the signature reaction, namely the reduction of the chromium +6 oxidation state to chromium +3 ion, formation of this nice bluish green colored ion, and the discharge of the orange-brown chromic acid. So that's good. Now in this case, because this is a secondary alcohol, we actually now have a ketone in there, 4-methyl-2-pentanone. Okay. So that's the reaction for the secondary alcohol. Now, the tertiary alcohol, let's put a little bit here in our test tube. Okay. A few drops, 1, 2, 3, 4, yeah, that's about it. Acetone as a solvent, so let's put that in there too. Okay. So we've got our tertiary alcohol in here, and acetone as a solvent. And now we're going to put a little bit of the oxidizing agent in there. Okay. You'll see that while there is a very slight color change, it's largely the color of what is now the dilute chromic acid solution, so that the tertiary alcohol resists the oxidation reaction that we saw for the two other alcohols, the primary and the secondary alcohol. So there it is. So we can distinguish now very rapidly between primary, secondary, and tertiary alcohols as our second category. And let's just bring these two up to you now. You can see, first of all, the results. Here we have the primary alcohol, presumably hexanoic acid in there, and we have the secondary alcohol, presumably 4-methyl-2-pentanone now, and we've got the unreacted 2-methyl-2-butanol tertiary alcohol. Now, if you let this test tube stand overnight, it eventually will react, but in a short space of time, we've been able to distinguish between the primary and secondary as a group and the tertiary alcohol as a group. So this particular test is really very convenient for those people who are trying to distinguish between those two classes of alcohols, primary and secondary on one hand, and then the tertiary alcohol on the other hand.